So I'm going to begin by introducing you to this guy. This is Antoine de Saint-Exupéry. He was a French aviator. Aviator is the word that we used to use for pilot back when aviation was really dangerous. And it was really dangerous because the planes crashed a lot. He experienced several crashes during his career and survived almost all of them. He was once trying to set a speed record from Paris to Saigon, but his plane crashed in the Sahara Desert just outside of Cairo, and he was not prepared for desert survival. So he suffered terrible dehydration. As a result of that, he stopped sweating, which in the desert is a really dangerous thing. He had awful hallucinations. Fortunately, he was rescued by someone who knew how to treat severe dehydration, and he recovered. The World War II was starting, so he went into exile in America, where he became a writer. It turns out he was a really good writer. He is best remembered for having written The Little Prince, which is a famous children's book. It's about an aviator who is stranded in the desert, who is visited by a strange little boy who lives on an asteroid and is suicidal. Like all the great children's books, it's not really a children's book. He also wrote books for adults. And in one of them, he wrote what I think is one of the best sentences ever written. He said, "It seems that perfection is attained not when there is nothing more to add, but when there is nothing more to take away." He was writing about the design of airplanes, but it seems to talk about everything which combines discipline and creativity. And I hear this quote being used all the time in architecture and design and everything, but I think it has a particular application to programming, because we have this real connection with perfection more than any other craft. Our programs have to be perfect. And if our programs are not perfect in every way, bad things happen. And he gives us some insight as to how perfection is attained. It's not by adding things, it's by taking things away. And it occurred to me that this should also apply to programming languages, that we can make our programming languages better by taking away things. So that leads to the idea of good parts, where a language can be made better not by adding things, but by removing things. And the principle of good parts says that if a feature is sometimes useful and sometimes dangerous, and if there is a better option, then always use the better option. I think this makes a lot of sense. A lot of people still think this is controversial, that you can't make me use the better option, which seems like an odd argument to make, but there's still a lot of people saying that. And I think it comes from a fundamental misunderstanding of what it is that we're doing here. We are not paid to use every feature of the language. At the end of a project, there isn't a manager with a clipboard saying, "Did you use a plus plus? Did you leave out any semicolons? Excellent." No, that's not what they're looking for. We are paid to write programs that work well and are free of error. Now, free of error, when did that become part of the deal? Well, it turns out it has always been a part of the deal. It is the most important part. It's just that we attain it so rarely that it's easy to forget that that's the most important thing about what we're doing. So my advice to everybody who wants to be a better programmer is to learn more languages, because a good programming language should teach you. And in my career, the language which has taught me the most was JavaScript. I had a very difficult relationship with JavaScript because in the beginning, I made every mistake with JavaScript you can make. Starting with the first one, the worst one, I started programming without bothering to learn the language first. And I thought I could get away with that because it looked familiar. I thought I understood how it worked, and it punished me for that. It punished me hard. Eventually, I decided to read the standard and try to figure out what the language actually did. And that completely changed my understanding of this language. It was not at all what I had thought of at first. It was actually a very different, actually a very good language, but until I read the standard, I had no idea that was true. Now, even though it's a very good language, it's a language that contains a lot of bad parts. And to help me manage those bad parts, I wrote a program called JSLint. Everybody should be using JSLint. You know, all of your code, everything should pass JSLint because it's important for us to write good stuff. And this is the best way to assure that it's good. And when I started writing JSLint, I had no idea about programming style. I didn't think style was important. I was just looking for errors. But JSLint taught me that programming style is actually very important, that increasing the visual distance between a good program and a bad one is one of the most effective ways we have to avoid making mistakes. So it turns out JSLint is a lot smarter about JavaScript than I am. It taught me more than I taught it. So I wrote my own book about my adventures with JavaScript and JSLint called JavaScript: The Good Parts. Anyone heard of this one? Yeah, a few hands go up. So it's still a bestseller in its category, which is really unusual. Most software books are obsolete at the time that they're printed. And this one has been out for 10 years and is still doing really well. And I think that's because it turned out what I identified as good parts were mostly right. And so there's still value in the book. That said, I'm working on another book, and I'm hoping to get it out for you this year. And in the process of going through it, it gave me a chance to sort of reevaluate and decide what actually is good and what is not. There is still an argument, though, about good parts, that there are some people who think that that concept doesn't apply to them. So I'd like to review some of the arguments about why we shouldn't care about the good parts. The first one is, it's just a matter of opinion. You say it's bad, I say it's good. All opinions are equally valid. That turns out not to be true. And the reason I say that is, so I'm the maintainer of JSLint, and I get reports from people from all over the world. And occasionally I get something from someone who says, we've just spent 2 bloody weeks chasing down some weird thing that turned out to be an obscure corner case in JavaScript that none of us had ever heard of, and it really was expensive to find this thing. Could you please put a test into JSLint so that no one will ever experience that again? And if their request makes sense, I put it in, which means that if you're using JSLint, that will never happen to you. That's not an opinion, that is a fact. Every feature is an essential tool. I need to be able to use every tool in the tool set in order to do my work. And it turns out that's not true. That you can do better work with just the good parts, with just the good tools. You don't need to use the tools that are rusted or have broken handles. If you can do better work without a broken tool, then that tool was not essential. But a feature is sometimes useful, and I should be able to use everything which is sometimes useful. And this sounds like a good argument, except it turns out that everything is sometimes useful. Humans are so creative, we can find a use for anything. There's nothing so awful or disgusting or bad that we can't find a use for. So saying that something is sometimes useful is saying nothing at all, because you can say that about literally everything. So if your only argument for using a feature is that it's sometimes useful, you do not even have an argument. I have a right to use every feature. So this sounds important. We're going to be righteous now. I have a right. And we're going to fight for our rights. We're going to do that. But if you take this argument to the end, do you have the right to write crap? Yes, I have the right. What? Why are we fighting about that? I mean, it doesn't matter if you have the right. What matters is you have the responsibility to write good programs that are free of error. I need the freedom to express myself. I'm a poet, and I express my poetry by leaving out my semicolons. I need to reduce my keystrokes. This is an important one. We think that we spend most of our time power typing. You think over the day, what did I do today? I was typing. I was going dot, 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 writing a program going dot, 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 dot. Except that's not actually how we spend our time. We spend most of our time staring into the abyss saying, my God, what have I done? So it's not the keystrokes, it's that. If we could figure out a way to spend less time doing that, we would be much, much more productive. The keystrokes are irrelevant. You could take all the clean, finished code that you produce in a year in a day. If all you were doing was typing in the program, I'm not saying it'd be a fun day, but in a day, you could type all the program that you write in a year. And that raises the question, what are you doing with the other 99% of your time? It's a lot of it's that. Then it's an insult to suggest that I would ever make a mistake with a dangerous feature. Obviously, someone who's less qualified than me would make mistakes with that, but I am so skilled that I can do stupid things and it's going to work. And that's not good. There's a good reason those features were added to the language. Now, I've been part of the standards process, so I can tell you for a fact that is not true. There are all sorts of reasons for why things can get into a standard, and they don't have to be good in order for that to happen. So Brendan Eich, who's the brilliant man who invented JavaScript, talks about foot guns. A foot gun is a feature that you use to shoot yourself in the foot. And he unintentionally put a lot of foot guns into JavaScript. And there are people who think that they're there to be used. So watch this. I almost always miss. Here we go. So the purpose of a programming language is to aid programmers in producing error-free programs. If you're doing anything else, you're doing it wrong. You're misusing it. So we used to think it wasn't possible to write good programs in JavaScript. So don't even try, just write slop because that's the best you can do. That turned out not to be true. That it is not only possible to write good programs in JavaScript, it is necessary. Because of all the badness in the language, you have to bring an extraordinary amount of discipline to the writing in this language. And that means you really have to write everything well. So there's a lot of confusion about JavaScript. For example, its crazy name. It seems to have the same name as another language called Java, and it's confusing. It's similar to the confusion between Star Trek and Star Wars, right? You've got two science fiction franchises that got spaceships and people fighting and stuff, and basically the same name, but the fans know they're really different, right? You can't confuse them. In Star Trek, you have phasers and photon torpedoes, uniforms, damn regulations. And in Star Wars, you have lightsabers and blasters, proton torpedoes, sand, chaos. I hate sand, by the way. So when you're working in Java, so which language is the Star Wars language, right? It's JavaScript, right? So when you're working in JavaScript, it gives you a choice. You can either go Jedi or you can go Jar Jar. And unfortunately, a lot of our brothers have decided to go Jar Jar. So I've observed two things, the fantasy of infallibility and the futility of faultlessness, two attitudes. I find the first one, the fantasy of infallibility, mostly in younger guys who think they can write mad, crazy code and it'll work. And they'll just take ridiculous risks just because. And then I see the futility of faultlessness mostly in older guys who are saying, it never works. It's never going to work. Why even try? So two very different perspectives, but they both lead to the same thing, danger-driven development, where you take unnecessary risks in the coding just to keep it interesting. So one of the things that makes programming so difficult to manage is the difficulty in scheduling. In order to schedule software, we have to figure out what time A is, the time it takes to write the code. And that's difficult because we're perfectionists. You know, ask a programmer, how long will that take? And go, oh, it's about that many keystrokes, da, 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 you know, forgetting about all that other time. But even harder than that is time B. Time B is the time it takes to make the code work right. Now, ideally, time B should be 0, right? You write the code, and it works right, and you're done. But that's usually not the case. Time B can be greater than time A, right? And I've seen cases where time B is infinite. That's what happens when a project is canceled after code complete because they could never get it to work. So we don't want to do that. If you're doing anything during time A which increases time B, you're doing it wrong. So we should always take the time to code well, because if the code is written well, it's going to be easier to make it work, and it's critical. Even if you're doing something cheap and dirty, something that's only going to run once, it still has to run at least once, and that's going to be easier to do if you write it well. Don't be sloppy. So there are new good parts in ES6. You've probably heard of them all. The best one, unfortunately, is not available everywhere yet. It's proper tail calls. If the last thing a function does is return the result of calling a function, either itself or any other function, the compiler is required to, instead of creating a call return sequence, it instead generates a jump. So it's essentially a go-to with parameters. And this can cause a lot of programs to go much, much faster. It also enables something called continuation passing style, which is a form of programming that was discovered in the functional programming scheme, which would be really, really effective in JavaScript if we had this feature. Unfortunately, Microsoft and Google have been very, very slow to implement this. So I'm hoping, if you know any of those people, tell them to get on it. We need this. This is the most important feature we got in ES6. Second would be the ellipsis operator, or the ... which can be used in calling sequences in parameter position or in argument position. In parameter position, it says, take all of the remaining arguments and pack them together into an array. So it's a very effective way of dealing with functions that need to take a variable number of arguments. And in calling position, it will spread the array out so that each element becomes a separate argument. So this is two versions of the curry function, modified so that it can take any number of arguments. The first one is the way you can write it in ES6. The second one is the way you write it in ES5. Which one would you rather have to maintain? Anybody? 6? Yeah, obviously. So I like that. That's good. Modules, we got modules, which was really good because browsers provide linkage in the form of global variables. And we know that global variables are evil. So modules give us an alternative to that. Unfortunately, I don't like the way modules turned out. They're much too complicated. I think modules should be simple, where a module can import whatever it needs and will export one thing. It's going to export a function or an object containing a bunch of functions, and that's it. You want to have the simplest interface possible. If you have a complicated interface, then it's not a good module. Modules should surround what they do, be really clean. And fortunately, there is a clean subset of the module syntax, and I recommend using just that and avoiding all of the tricks and weird stuff. We have let and const in the language. Let is the new var. The difference between let and var is that var ignored block scope and let enforces block scope. It turns out you don't need block scope to write good programs, but that's all the Java guys know. So if you just have var in the language, they get confused, and that's not good. That's not good, right? When the Java guys get confused, that's trouble. So if we have let in the language, they don't get confused as much, and that's good. So I recommend using let only for that reason. And we also have const, and that's good too. I actually like const better because it discourages the use of assignment, which gets us away from mutability, which gets us a little closer to purity, which is mostly a good thing. We have some new syntax called destructuring. Unfortunately, that can get too wild too, but there is a simple form of it which I like a lot, where in this case, we're going to create two variables, that and other, and we've got an object on the other side, and that will be initialized with some object.that, and other will be initialized with some object.other. This doesn't allow us to do anything that we couldn't do before, but there are some idioms which are much cleaner, much more readable in this form, so I'm liking this. We have weak maps. Weak maps are really important. Weak maps are the way that objects should have worked in JavaScript. JavaScript only allows strings to be used as keys in objects, but there are times when you really want an object to be a key in an object. And JavaScript doesn't allow that, but weak maps do. So we didn't fix objects, we added another thing. And weak maps also work well with the garbage collector. So if you have an object and the only place it exists is as a key in a weak map, then it will automatically be deleted. So there are certain forms of memory leaks which are avoided if you use weak maps. The problem with weak map is it has the worst name of any feature of a programming language ever. Nobody wants to use something that's weak, right? But it's really good. I really like weak maps. It allows us to write programs that we could not write in the language before. We have megastring literals, which are big. I'll show you them in a minute. First, let's look at a regular expression. Anyone guess what this matches? Of course not. These are terrible. It's really, really hard to read regular expressions. But what I can do is I can wrap the regular expression constructor with something which takes a string and deletes all the white space from it. And using the new literals, I can now write it like this. So this one you can read, right? So what this is it matches all of the number literals that are in ES6. So we have binary literals, octal literals. We've always had the hex and the floating point. So which one would you rather maintain, the top one or the bottom one? I'm thinking the bottom one. Yeah. So, but it's still a really weird and nasty notation. I wish we had something better, but we don't. Until we get something better, and I'm not confident that we ever will, every time I write a regular expression, every time I run it through regex. Regex is something on the web which will take a regular expression and show it to you as a railroad diagram. So you trace the train around the tracks, and that shows you what the thing matches. And it makes a lot more sense than that does. What else we got? So we added a lot of bad stuff in ES6. And it was all well intended, and people had good reasons for why they wanted it, but we shouldn't have done any of it. So proxies were intended to be a solution to the no such method problem, but it turned out to be way, way too complex. Generators were completely unnecessary. If you know how to write a function that returns a function, you don't need generators. In fact, I think you should have to understand a function that returns a function in order to get a JavaScript license. We added iterators, don't need them. Symbols, we don't need them because we have weak maps. Whatever you could do with symbols, you could do with weak maps. Just don't need it. Reflection, we don't need. Oh, and the fat arrow functions. So that was highly requested by a lot of the functional guys. And their argument was that the problem with the function expression was there was too much typing. You had to type F-U-N-C-T-I-O. That's too much to type, can't do that. I said, well, there's this new thing called keyboard macros. So you just, it's too much to read. So, okay. So we put this in. But I don't like it because it looks too much like a relational operator. So it's, I think, easy when you're scanning a program to miss the fact that this is a function, because it looks like it might be a comparison. But anyway, what this one is it's a little function. We don't have to say return. We'll just return a thing. So it's going to take a name and return an object that contains an ID property of that name. So we made a tiny little constructor. So that's pretty neat. Except that this is not going to return a new object. It's going to return undefined. So if you look at the code, is it obvious why it returns undefined? It looks like it should. Yeah, we keep doing stuff like that. We take stuff that looks like one thing, and except it doesn't work. And you don't get any warning that it doesn't work. It's just bad. So for that reason, I recommend it's just not worth it. For the number of keystrokes you save, given this potential syntactic hazard, I would just rather not use them, which is a shame. Now, by far the worst new feature in ES6 is class. This one was strongly recommended by all of the Java guys who are having to write in JavaScript now, who don't want to have to learn a new language. And so this gives them the illusion of writing in a language that they think that they already know, except we didn't really add classes to JavaScript. It's just syntactic sugar on top of the prototype stuff, which kind of works the same, but kind of doesn't. And so there's some places where people are going to get surprised because it doesn't work the way they think it does. And whenever you have that kind of confusion, bad stuff happens. But worse than that, if you're content in writing in this style, you will never understand how to use JavaScript as a functional language. And it's so much more fun and pleasant to be writing in JavaScript in that way. The people using class will never learn that, will never experience it. They will go to their graves never knowing how miserable they were. So in the good parts, I recommended that you not use new. You should use object.create instead. And I managed to get object.create added to ES5 just so that I could use it. So I was pretty happy about that. So I was kind of surprised when I noticed that I have stopped using object.create. And the reason for that is that I stopped using this. That if you're not using this, then object.create doesn't really do much for you. And the reason for that, about this, is that in 2007, I did an experiment called AdSafe. There were a bunch of projects, including FBJS at Facebook and Web Sandbox at Microsoft and Kaha at Google and my own AdSafe project. We were all trying to figure out how can we make JavaScript safe so that we could allow a third party to run in a page and not get out of hand, stealing stuff and doing bad things. And the problem everyone had to deal with was if you have a method and you call it as a method, everything's fine. This gets bound to the object of interest. But if you take that same method and call it as a function, this gets bound to the global object, which gives away all of our security. How do you get around that? So the approach that the other projects took was doing code rewriting. So they would read a JavaScript program and rewrite it, adding lots of indirection and runtime checking to make sure that this didn't get out of hand. My approach was much simpler. I said, let's make this illegal. If we see a program with this in it, we won't let it run. We reject it. That's really simple to implement, and it doesn't make debugging harder, and it doesn't slow down the code, which was a problem with the other systems. The problem was that 0% of all existing JavaScript programs would go through. And so I just said, well, if you take away this, it's still a Turing-complete language, so we should still be able to do everything that we need to do. So to test that hypothesis and to get an understanding of how painful it was going to be to do this transition, I started writing in a dialect of JavaScript that didn't have this in it. And I was very surprised to discover that it didn't get harder, it got easier, and my programs got better. because I was having to do function stuff and not doing class stuff, and everything was great. So I now recommend everybody stop using this. I stopped using null. So JavaScript has two bottom values, null and undefined. And there's an argument in language design, should you have any bottom values? But nobody thinks you should have two of them. And JavaScript has two of them, and people are confused. When you have two things which are very similar but not the same, that creates confusion. Some people think you can use them interchangeably, but you can't, because in some cases they behave differently, and that difference is a source of confusion that causes bugs. So I decided to get rid of one of them, and the one that I can get rid of is null, because the system itself uses undefined. Undefined is the value of an uninitialized variable or a missing property, and so that's the one the system uses, and that's the one that I use. I stopped relying on falsiness. You know the falsy values, everything is either truthy or falsy. Brendan did that because of C. C is an undertyped language, so C uses a single value, 0, to represent null, false, the end of strings, 0, and some other stuff. And Brendan wanted to be able to do the same kind of stuff when writing in JavaScript. And I now think that that was a mistake. I think Java got this one right, that in a condition, that value should better be a Boolean. It shouldn't be boolish. I don't use for anymore, because in ES5 we got these wonderful new array methods, like foreach and map and reduce and all those others. So most of the time you use a for statement, it's because you want to visit each element of an array, and it's much, much better to use these things. You don't have to ever do the plus plus stuff. All of that happens automatically. All you deal with is what you want to happen for each element. It's a much better way of writing programs. So I stopped using for. I don't use for in, because I managed to get object.keys added in ES5, so it now returns a nice array of the own properties of an object, so you don't have to worry about what might get dredged up on the prototype chain. And then you can take that array and pass it to for each. It's just a much nicer way to deal with the stuff. And when ES6 is finally implemented everywhere, then we'll have proper tail calls, and I will stop doing while. So here are two versions of the repeat function. You pass repeat function a function, and it will call that function over and over again until it finally returns undefined. The first one is using while to do that. The second one is using tail recursion to do it. It's returning the result of calling itself. The ES5 or ES6 spec requires that these both run at the same speed with the same memory pressure, so there is no longer a performance penalty for using tail recursion. And when that finally becomes available, I will be done with loops. I'm going to be writing all of my repetitive stuff this way forever. So I've been thinking a lot about the next language, the language which replaces JavaScript. And I believe that we have to have a next language, because if it turns out that JavaScript is the last language, that would be really sad. We shouldn't stop there. We should find something better, if only for your children, right? You don't want your children writing in JavaScript. So what's the next language going to look like? And it's not clear. It's not clear because programmers are as emotional and irrational as normal people. Now, that may sound really insulting that I'm comparing you to normal people, but it's true. And why do I think that's true? Well, let me show you my evidence. It took a generation to agree that high-level languages were a good idea. It used to be that all programs were written in machine language, where you had to enter every single instruction, and it was a lot of work and very easy to get things wrong. And then Fortran comes along, and in Fortran you just write things that look like equations. They called it automatic programming at the time. The idea was that the computer would write its own programs. You just tell it what to do. And so it was so much easier. And who would benefit from that more than anybody else? The programmers. And who refused to use it? The programmers. Had a similar thing happen with the goto. Dijkstra writes his letter to the CACM in '68, suggesting that goto should be eliminated from all languages, replaced with while and if then else. And that starts a bitter argument that goes on for 20 years. And I remember that argument. It was loud and noisy and crazy, people saying, you can't take the goto away from me. It's an essential tool. It's how I express myself. I'm a goto guy. I have a tradition. My grandfather used a goto. It took a generation to agree that objects were a good idea. Objects are first discovered in Simula, and being one of the most important breakthroughs in programming, the world took no notice of it at all, except for one grad student at the University of Utah who thought that this object idea was so powerful he could use it to create a programming language for children. And that eventually leads to object-oriented programming. In 1980, or 85, I think, the industry had a choice. What was going to be the dominant object-oriented programming language? It could either be Smalltalk 80, which was the best, most carefully designed programming language in history, or C++. And we chose C++, and that decision was made by people who fundamentally didn't understand what object-oriented programming was, and they chose C++ because you didn't need to understand what object-oriented programming was in order to use it. And we were still paying the price for that. All of our languages since then have followed the C++ heredity and not the Smalltalk heredity. Then it took 2 generations to agree that lambdas were a good idea. Lambdas were perfected in the scheme language, again in the early 70s, and the world took no notice of it. And it took so long to get to the mainstream that some thought it's never going to go to the mainstream because if it were a good thing, it would have happened by now. But it is happening now. Anyone know what the first programming language was that brought lambdas to the mainstream? Any guesses? It was JavaScript. JavaScript was the first one, followed by Ruby and Python and C#, and eventually PHP got it before Java. Is that embarrassing or what? So the reason each of these things takes so long is that we don't change minds. We have to wait for a generation of programmers to retire or die before we can get critical mass on the next idea. I remember when the goto thing was going on, and it was really loud and hot, and people were getting really upset and making ridiculous arguments. And then one day it was quiet. It's like, are they gone? Can we get rid of it now? Yeah, we got rid of it and everything was fine. That during the argument, there were all these complaints about, or predictions about bad things that were going to happen, almost threats, that if you get rid of goto, the consequences are going to be terrible. And we got rid of goto and everything has been fine. And in fact, the major benefit of getting rid of goto is that it is easier to write programs of greater complexity. That having goto, complexity became overwhelming much earlier. That by going structured, we could make programs much bigger, more sophisticated before the complexity becomes overwhelming. So again, who benefited from that? It was us. And who rejected it? Again, it was us. So that's why I think it's going to be a problem with the next language, because when the next language appears, we will all say, no, none of that. We don't want that. So looking at languages, I would try to put them into 2 classes: systems languages and application languages. A systems language is something you'd use to write a kernel or a memory manager or a device driver and nothing else. Everything else should be written in application languages. And we have a problem with systems languages because the dominant systems language today is still C. And C comes from the late 60s. We have lost the ability to innovate in systems languages. I think that's shocking. But I'm more concerned with application languages because that's where we live. That's where we spend most of our time. So I would take the application, and I think every language should clearly be on one side of that line or the other. I think the biggest design error in Java was it couldn't decide if it was a system language or an application language. And so it tries to have one foot in each boat, and that's a problem. One of the consequences of that is that it requires the use of threads in applications, which is a really, really bad idea. So you can take application languages and split them into two classes, those that use classical inheritance and those that use prototypal inheritance. The classical languages are almost all of the languages, and the prototypal languages are pretty much just JavaScript. And for a long time, I was a big advocate of prototypal inheritance because one of the problems that you get with the classical stuff is it comes with a lot more work. First off, when you're designing your system, you need to do a classification. You have to identify all of the different types of objects you're going to have, and those will become your classes. And then you have to work out the taxonomy. You have to figure out what is going to inherit from what, what's going to implement what, what's going to provide an interface to what. And we're doing that at the stage of the program when we have the least understanding of how that should go together, usually at the beginning. First we have to design the hierarchy and then we'll implement it. And because it's such a difficult problem, it's inevitable that we get it wrong. But we go ahead with this broken taxonomy and we find that things aren't quite right, that classes don't compose the way we would want them to. We find we wish that we had multiple inheritance because we just can't get stuff to go together. And that whatever is broken in the bottom layers starts to work its way into the higher layers as well, that there's leakage and everything gets broken. And eventually it gets so bad that you think you have to refactor, which means that you have to tear everything apart and try to put it back together the right way. And that's really scary because it might not ever go back together. And so we don't want to do that either. And people who live in the classical school assume that that's just inevitable. All programs have to live with that. That's just a fact of life. And it's not. That's a characteristic of classical programming. And that doesn't happen in prototypal programming because you don't have the tight coupling that classes have with extends. And so the programs just compose much better. So with prototypal inheritance, we avoid all of that stuff. And there was another advantage, which is memory conservation. So the major advantage to using object.create instead of object.copy to make instances is that object.create uses less memory because we can inherit properties instead of copying properties. And that may have made a lot of sense in 1995 when the language was designed. It doesn't make sense anymore. Moore's law has been so incredibly generous on memory capacity that the old way of thinking is completely ridiculous now. You all have at least, probably several gigabytes of RAM in your pocket. The way we should think about memory is completely different. But we're still programming like memory is a very constrained resource. It's not anymore. It's also a source of confusion because we have own properties and inherited properties, and sometimes they behave the same and sometimes they don't. And anytime you've got things which are kind of the same but not, you have a source of confusion which can lead to bugs. It also provides for a retroactive heredity where we can change what something inherits after it's been constructed. I've not found any good uses for that, but I've seen some very, very bad uses for that. It also tends to inhibit performance, that modern JavaScript engines get speed by making assumptions about the shape of objects, but they have to be pessimistic about prototype chains because a prototype chain can change without notification. So I no longer recommend prototypal inheritance. I'm now an advocate of class-free object-oriented programming. I think class-free object-oriented programming is JavaScript's gift to humanity. So this is block scope. You all know what block scope is. We've got two blocks, each defines a variable, A or B, and the inner block can see both variables, but the outer block can only see its own variable. So because a block hides stuff, which is a good thing. And all languages, even JavaScript now, can do something like that. And the same thing also works for functions, because a function is just a block with some extra plumbing on it, which allows the block to be executed somehow in the future. And we've still got this relationship where we can diagram the variables. So variable A, or the green function has variable A, and the yellow function has access to A and B. And so this concept is called closure, talking about sets, that one set closes over the other set. And it took a long time to figure out how to implement this because of this case. What happens if the inner function survives the invocation of the outer function? For example, if the outer function returns the inner function wants to have access to A, but A disappears when the green function returns. It turned out that the solution to that was trivial. We just allocate everything on a heap instead of on a stack and let the garbage collector clean it all up. And so that's what JavaScript does. So having this is how I recommend making objects in JavaScript from now on. So I've got a constructor function which will take a specification object. We could take individual parameters, but I like having them all in one object. That means we can use an object literal, and that allows the arguments to come in any order. And if there are any that we don't need, we can simply ignore them. And if there are any that are missing, we can easily provide defaults. I once wrote a constructor which had 10 arguments. And it was really hard to use because nobody could remember what order they were in. And after a while, we discovered that nobody ever used the third parameter, but we couldn't take it out, right? Because all the programs, if I instead had a specification object, then we could have gotten rid of that parameter and it would have been easy. And the specification object could also be a JSON payload, right? We could get something over the network which tells us, constitute an object with these properties, and it'll make it for us. So I will initialize member variables from the specification object. And then I can call other constructors and take the functions that they return and copy them into my own other variables. So these are the other methods that are going to be available to us. And then I create my own methods. And because of closure, my own methods will have access to all of the member variables, all the other methods, all of our other methods, and the specification object. And we don't use this. And then I list all of the methods that need to be public, and I export them and I freeze the object. Freezing is really important here because it allows us to have a high integrity object. It cannot be confused or corrupted. The only way to get access to the member data is through the methods. That gives us highly reliable objects. It's the only way to get highly reliable objects in this silly language. So this is the way that I recommend that we be making objects in the future. We don't need this. So thank you and good night.
Thank you for your speech. I have one question about WebAssembly. What do you think about WebAssembly?
Where are you? Oh, there you are. So the thing that, the only benefit that I see from WebAssembly is that some things will go faster. And most things will not go faster because they're already fast enough. So if you have something that really has to go really fast in a browser, then I guess it's a good idea. But it comes at a significant cost in other ways, and for most applications, I think it's just a distraction.
Thank you.
Thanks for your speech. It was really amazing. I have a question. In both of your talks, you mentioned that generators are not as good as you might think, and a lot of users might think, but you didn't mention actually the reason, because like from my opinion, and not only from my opinion, it represents and illustrates how our minds work, because our minds doesn't work in terms of asynchronicity, like it's streamline instructions. So do that, then do that, and etc., etc. So actually, Kyle Simpson in the offer of You Don't Know JS series also mentions that it's really, really good feature of ES6. So I'd like to know and curious about why do you think that it's not as good as we might think?
Well, first off, it's unnecessary. And anything which is unnecessary, I think we should get rid of it, because I think a smaller language is better than a bigger one. But it makes control flow much more complex. It breaks some things that used to be invariants in the language, because things can go in and out. You can be in weird state. The syntax is really ugly. It looks like it's going to return a function, and it's not returning a function, so it's deceptive and confusing. And it's unnecessary. I don't see any value in it at all. And your argument about it's the way we think, that's the thing we need to change. That we're talking about a paradigm shift, right? So granted, the other side of the paradigm shift will take some hours of experience, but once you've accomplished that, then you'll see that the how we're used to thinking about things argument is holding us back. It's not helping us go forward.
So if you were creating a new language, you would leave only higher order functions as the way to handle asynchrony world in JavaScript or whatever language?
Yeah.
So it's only thing, a feature we need to use to handle all asynchrony world, right?
Yeah.
Okay, thank you.
Thank you very much, first of all, for trolling ES6 classes users. But I haven't get still what's wrong with arrow functions.
Well, I thought I explained it. They are visually confusing. They don't look like functions. They look like conditions or relations. And there's that syntactic error that they cannot return objects. Or it looks like a valid thing, which might not produce a syntax error, but doesn't mean anything like what you think it means. So the saving of writing a keyword, I don't think is worth the cost. The other benefit that you get is that the binding of this is better, but I recommend not using this anyway, so there's no advantage to that.
Thank you.
Hi. I actually have two questions, but they're really short. You mentioned about JSLint. So I will be interested in what do you think about prettier, which is like enforces you to write in a certain style that not everyone might like, and it's hardly configurable, but it makes at least code consistent. And second thing you mentioned about like trying to make less errors in your code. Do you think TypeScript can be a solution to that, or at least to, like, what do you think about introducing types in JavaScript?
No, TypeScript is not a solution to that. So the theory about types, and it's an interesting theory, is that types allow the compiler to find a large class of errors at compile time, which is great. But you don't actually get much benefit from it because you still have to test, right? There's no type system which is so good which, you don't have to test anymore because the type system is taking care of it. That's not the case. You still have to test. And it turns out the sorts of bugs that the type system can find, your tests find instantly. So the bugs that are found are the lowest value bugs. The bugs that keep you up at night, the type system does not help with those and actually helps to cause those. That the type system doesn't want to write some kinds of programs that you need to write, and so you have to circumvent the type system, or you have to turn it off by casting or some other mechanism. So when we account for it, we tend to give the type system the value of all of the bugs that it found, but we don't subtract the value of the bugs that it missed, and we don't consider the value of the bugs that it caused. And I think when you take a full accounting of types, that they're just not worth it.
Thanks a lot.
Okay, thank you.